Hello guys, today's topic is trigonometry. So let us first learn what is trigonometry. Trigonometry is the branch of mathematics that deals with the sides and angles of a triangle, especially the right angle triangle. Okay, so first of all, understand that what it is. Okay, now it is saying that especially about right angle triangle, but it is not exclusively about it. We'll see that later. Uh, First, learn how to pronounce it. If you want to follow the UK English, then you should say trigonometry. And if you want to follow the American pronunciation, then it should be trigonometry. Okay, so normally people call it trigonometry. Okay, study of trigonometry can be classified into three parts: core trigonometry, which deals with only right angle triangles; plane trigonometry, which deals with all the 2D shapes like a triangle, square, rectangle, or maybe ellipse, or something like that, anything 2D. That is called as plane trigonometry. And spherical trigonometry means it basically deals with all the 3D shapes. So a sphere, a pyramid, all these will cover in spherical trigonometry. So what are the basic concepts? These are the concepts that you need to know before we even start. What is an angle? Angle is a measure of space between two intersecting lines. Angle can be measured either in degrees or in radians. So what is radian? So pi radian means 180 degrees. So pi by 2 means 90 degrees, and 2 pi means 360 degrees. Okay. Uh, Again, acute angle means an angle lesser than 90 degrees. Obtuse angle means an angle greater than 90 degrees. Okay. Trigonometric angle means whichever angle is under consideration while doing trigonometric discussions is called as a trigonometric angle. Means normally you draw a triangle, you write theta over there, right? That theta is basically a trigonometric angle. Okay, means whichever angle is under discussion, under trigonometric discussions, you call that angle as trigonometric angle. What are the standard angles? 0, 30, 45 degrees, 60 degrees, and 90 degrees. Complementary angles are those angles whose sum is 90 degrees, and supplementary angles are those angles whose sum is 180 degrees. Okay, this is very basic thing, so that if I use some of these terms later on, then you should not get confused. And that's why I told you about these basic terms. What are trigonometric ratios? So sine, cos, tan, cosec, sec, and cot. These six are trigonometric ratios. They are also called as basic functions of a trigonometric table. Okay. So sine theta means opposite side upon hypotenuse. Cos theta means adjacent side upon hypotenuse. So this is the trigonometric angle that we are talking about. So sine of this angle is opposite side upon hypotenuse. Now imagine that this triangle is elongated a bit like this. Okay, even then this opposite side upon this big hypotenuse is also the same. Okay, the ratio remains the same, and that is why uh, sine theta is basically a function of theta. It is not the function of sides of the triangle. It's basically, it depends upon this angle. So unless so as long as you keep this angles the same, no matter how long, how wide you stretch this perpendicular, you keep on moving it towards the right, still sine of theta will remain the same. Okay, so this is the whole concept. That's why it's given in terms of ratios. So since it is given in terms of ratios, it does not have a unit. So sine theta does not have a unit, because suppose the opposite side is of 3 centimeters and hypotenuse is of 5 centimeters, then actually sine theta is 3 centimeter by 5 centimeter. Centimeter will get cancelled, and it means it is just a ratio. It does not have a unit. Okay, it's just a ratio. So 3 by 5 is sine theta. Okay, similarly cos theta would be, let us say this is 2 centimeter, so it is 2 centimeter by 5 centimeter, so 2 by 5. Okay, that will be cos. Till here you should remember sine and cos. You have to remember these two formulae, but all the other formulae I'll give you tricks to remember them. Tan theta, you can remember it as sin theta upon cos theta. So what will that give us? The denominator will get cancelled, so it was opposite side upon adjacent side. Cosec theta is 1 upon sin theta, so it is inverse of sin theta, so it is hypotenuse upon opposite side. Sec theta is the inverse of cosec theta, so you will get hypotenuse divided by adjacent side. And cot theta is inverse of tan theta, so you'll get adjacent side upon opposite side. Got the idea? Now, yeah, I'll also emphasize that cosec theta, when I was young, we used to write it as cosec, the whole thing. But nowadays, schools teach children to write it like this, CSC, which is actually very confusing. It's difficult to remember. Even it's difficult for me also to remember CSC of theta. The reason is, see, sine, you can say something about it. Cos, you can pronounce it. Tan, you can pronounce it. CSC, you cannot pronounce, and that is the main problem. But still, the newer way of calling it is CSC of theta. Actually, our way was better because we used to pronounce it just the way we used to write it, and that was cosec. Okay, that is how it is. Now, I'll tell you a trick to remember sine and cos values of the standard angles. So get your right hand. Here you just name your fingers like 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now let us say that you want to find the value of sine 30 degrees. So 30 degree finger is this. When you say sine, find the number of fingers below the finger under consideration. So finger under consideration is what? 30 degrees finger. Okay, so there is one finger under it. Okay, so the first answer is 1. Now just divide that answer by 4, so you get the answer 1 by 4, and then take the square root of the whole thing, so it is 1 by 2. So sine of 30 degrees is 1 by 2. Okay, let's do that again for some other angle. Let us say sine 45 degrees. So this is the 45 degrees finger. Okay, so how many fingers are below it? 2 fingers, right? So if 2 fingers are below it, the first answer is 2. Then divided by 4, so it is 1 by 2. And then take the square root, so 1 by root 2. So 1 by root 2 is the answer of sine 45 degrees. Got the idea? Similarly, if you want to find cos of something, then the same right hand trick can be used. Let us say cos 30. So 30 degrees finger is this. Now in the case of sine, we used to count the fingers below the finger under consideration. Now we will count the fingers which are above the finger under consideration. So finger under consideration is 30 finger, right? Because we are finding cos 30. So how many fingers are above it? 1, 2, 3. Okay, so the first answer is 3. Then you divide it by 4, and then you take the square root of the whole thing, so it will be root 3 by 2. Okay, so cos 30 is root 3 by 2. Similarly, let us say 45, again 2 fingers are above, so this will be 2, divided by 4, so it will be 1 by 2, take the square root, so 1 by root 2. Got the idea? This is how you calculate sine and cos for the basic angles. Now this is possible because these basic angles, these standard angles are only 5. You have 5 fingers in your hand, that's why you can do that, right? And believe me, this is more than sufficient, because many questions that you're basically asked in your school are normally about standard angles. They don't ask you about 15.2 degrees. They won't ask those questions. They'll normally give 30 degrees, 60 degrees, 45 degrees, that kind of angles only you will get. Okay, so this is a very good technique to remember sine and cos values of the standard angles. Then this is called as a trigonometric table, where these are trigonometric ratios. So all the ratios are given here, and then these are all the standard degrees, and then various values like sine 0 degrees will be written here, sine 30 degrees will be written here, and so on and so forth. So how many values do you have to remember in a trigonometric table? 1, 2, 3, 4, 5. 5 into 1, 2, 3, 4, 5, 6. 5 into 6 is 30 values. How will you remember? I'll tell you a trick. So first of all, you draw the table. That is your step number 1. Then what you do? calculate the sine values using your right hand technique. Always remember it is a right hand, huh? Right hand. That is why this is 0 degrees. That is why. Okay. If you take the left hand, then also if you consider this to be 0, then if this is 30 degrees, then sine of 30, for that calculate all the fingers which are below the finger under consideration. Okay, so here you used to go towards the left for sine, here you'll have to go towards the right for the sine. Okay, so that's why pick any one finger, any one hand, and you remember the way to calculate it. Okay, and better way to remember it is, don't remember whether you're going towards the left or right. Remember that for sine you go below, so even in left hand you'll go below, and for cos you'll go above. In the right hand side, right hand, as well as in the case of left hand also, you'll go above in the case of cos. Okay, so pardon me, this is not a very I said something to the left instead of left. I should rather be saying above. Let me correct that for you right away. So sorry, left means below, fingers below the 30-degree finger. Count the fingers below 30 degrees finger, and here I'll say count the fingers above. Okay, so this is how it is. Okay, so coming back to our trigonometric table, first you drew the table. Okay, then you used your right hand technique or left hand technique, whichever technique you want, to calculate the value of sine of standard angles. Then for cos, just reverse it. So here for cos you'll be saying, see, sine of 90 is 1, na? You'll say cos of 0 is 1. And similarly, this value you copy here, this value you copy here, this value you copy here, this value. So it is as simple as that. You're just copying the values in the reverse order. Copy the values from sine row into the cos row, just copy it from the reverse order, in the reverse order. Okay, so that will give you cos. Tan is what? Tan is just the ratio of sine and cos, right? So just divide it right away. 0 divided by 1 is 0, this divided by this is 1 by root 3. It's very basic, right? You can do that. And anything divided by 0 is undefined, right? So this will be undefined. Then for cosec, you must remember that cosec is equal to 1 upon sine, right? So just do 1 upon sine. So 1 upon 0 is undefined, 1 upon half is 2, 1 upon 1 by root 2 is root 2, and so on. For sec, you must have guessed by now, sec is the reverse of cosec. So you know this, I'm just writing it in the reverse order. Alternatively, sec is also 1 divided by cos, so you can say 1 divided by 1, 1 divided by root 3 by 2. So it is just flipping flipping the ratios over here can also give you sec. Okay, and cot, as you know, is 1 divided by tan. So just flip the ratios over here. Okay, to get this. This is the way you get the trigonometric table for standard angles. Okay, now trigonometric identities for complementary angles. It's a fancy name of these formulae. So when I say sine theta is equal to cos 90 minus theta, this is what this is called as trigonometric identity. Okay, identity means ideally it should not be called as an identity. I'll tell you why. Because identity are those functions or those yeah, those functions. See, what is the difference between expression and function? Expression does not have equal to sign, functions have equal to sign. Okay, now when one of the sides of a function is 1, then it is called as an identity function. Okay, so this is not actually an identity, but in all the study materials I have I found it to be called as trigonometric identity. So I'm telling you what the textbooks say, but I personally don't think it is an identity. But anyways, if you are asked in the school, you should say, yeah, trigonometric identities for complementary angles are these. So sine theta is equal to cos 90 minus theta, cos theta is equal to sine 90 minus theta, tan theta is equal to cot 90 minus theta, cosec theta is equal to sec 90 minus theta, sec theta is equal to cosec 90 minus theta, and cot theta is equal to tan 90 minus theta. If you understand what am I doing here, let us see that in a diagram. Suppose this is a circle, and suppose I just draw one line like this, okay, and that line will automatically cut the circle somewhere. Let's call that point as Q. So the coordinates of Q are what? Let me take the laser pointer. Coordinates of Q are what? X comma Y. What is X? X is this, this much part. OP is X, and Y is what? OR is Y. Okay, that is the coordinates. Now when I say this angle is suppose theta, so when I say sine of theta, what it basically means is this is Y upon hypotenuse. Okay, so let us call this side divided by hypotenuse. Okay, now what is 90 minus theta? This angle, right? Because the addition of these two angles is 90 degrees. So 90 minus theta is this. So if I find cos of this 90 minus theta, it means the adjacent side upon the hypotenuse. Got the idea? So sine of theta is this upon hypotenuse, and cos of 90 minus theta is this upon hypotenuse, but this side and this side are equal, right? And that's why you can say that sine theta is equal to cos 90 minus theta. Got the idea? Similarly, you can calculate all these formulae based on this particular diagram. Okay, so this diagram is using two angles whose addition is 90 degrees, and that's why these trigonometric identities are for complementary angles, means angles whose sum is 90 degrees. Got the idea? Okay. Similarly, we have trigonometric identities for supplementary angles also. Okay, supplementary angles means those angles whose addition is 180 degrees, right? So how will you do that? Suppose this is a diagram, or there is a circle. I am drawing one line having which makes theta degrees angle with the x-axis, and I am drawing another line, this red one, having an angle with x such that red one's angle is red one's angle plus blue one's angle, they add up to make 180 degrees. Okay, so now I have drawn them like this, but now just imagine that this red one, I'm just flipping it like this. So what will happen? This will be minus x, and this one will just overlap this particular line. Got the idea? So addition of these two angles will be 180 degrees, and that's why they are called as supplementary angles. Okay, now in their case, now imagine, let me just tell you about this one first formula. Rest of the formula you can derive on your own. First formula, just think about it, just understand it, try to understand it. Sine of theta means what? Y upon hypotenuse, which is the radius of the circle, right? Now when I say sine of 180 degrees minus theta, so actually sine of an obtuse angle, it's very difficult for us to calculate, right? So let us imagine that in sine theta we used to say this upon hypotenuse. Now in for sine of this big obtuse angle 180 degrees minus theta, let us call it this upon again the hypotenuse. So what is the hypotenuse? It is this side. So this side is again what? It is the radius of the circle, and that's why both these things are equal. Okay, so 180 sine of 180 degrees minus theta is equal to sine theta. Take the example of cos theta. I told you that I'll go with only one, but let's go for cos theta as well. When I say cos theta, why is it negative? That's what I really wanted to stress upon. So why is it negative? Because cos of 180 degrees minus theta means what? It is basically, let's imagine this particular angle. So it will be what? It will be y by sorry, sorry, adjacent will be x, but it is minus x divided by whatever is the hypotenuse. Okay, cos of this guy would be x divided by hypotenuse. So they are equal in measure, but they are negative. Why? Because this x is actually minus x. Okay, and in the case of theta, it is plus x, but in case of 180 minus theta, it is minus x. That's why here minus sign comes. Okay, even if you remember this much, or at least remember the logic by which I was saying it, even if you don't understand the logic completely, it's okay, absolutely fine, but remember what I said. Okay, and that's why in the case of cos, since that's x is negative, this negative sign is coming. So in the exam, you can always just draw this figure and you can write these formulae down on your own. Okay, it is that easy. You will be able to write it down on your own. Okay, uh, just remember this formula and just remember the way I explained it to you. Even if you don't understand what I said just now, but remember the way I said, this is positive x, this is negative x. That's the reason why we do it like this. Now these are what? These are supplementary angles, 180 degrees minus theta, and this is theta. So these are supplementary angles. These are not supplementary angles, but still these are also called as trigonometric identities for supplementary angles. I don't know why, but this is what the study material says. Okay, so remember all these formula, try to remember them. After using them so many times, after using it frequently, you will remember what is the formula itself. Okay, you won't have to go back to the figure and try to find out what the formula is. You will automatically, these formulae will get memorized. You don't have to mug them up. Automatically they will sink into your ROM, I can say. They'll sink into your permanent memory automatically. Now, trigonometric identities. When you say these are also trigonometric identities, but they are not about complementary or supplementary angles, because 180 degrees minus theta or 90 minus theta is not given here. Okay, but these are also trigonometric identities. They have special name. This is called as Pythagorean identity. This is called as secant tangent because it speaks about secant and tangent. This is cosecant cotangent because it speaks about cos and cot. Okay, so this is these are also identities, but you don't call them as supplementary or complementary because you don't have 180 degrees minus theta or 90 degrees minus theta respectively. Got the idea? And names are very self-explanatory. Secant tangent means it has secant tan. Cosecant cotangent means it has cosecant cot. Okay, this one Pythagorean you'll have to remember. That is sine square plus cos square is equal to 1. Here sine should not be in capital. Okay, yes. So these are trigonometric identities. Now, very important question can be asked if you are a 9th standard student. It can be asked that prove all these identities. So let us see how to prove them. Let's prove Pythagorean identity, that is sine square theta plus cos square theta is equal to 1. This is very, very basic, and this will be a very easy question if it comes in your exam. At least this much you should be able to answer. So Pythagoras theorem, what does it say? It says that hypotenuse is equal to opposite side plus hypotenuse square is equal to adjacent side square plus opposite side square. Right now, divide both the sides by hypotenuse square. So what will it be? Here it will be this. Here it will be this. Now this h square will get distributed amongst these two, right? And this evaluates to 1. And then this square can be put across both of them. Okay, but then you already know what is a divided by h, means adjacent side upon hypotenuse. Do you remember? That is cos. And what is opposite divided by hypotenuse? It is sine. All right, so I've written it like this. I flipped it a bit just to see that, just to show you that this formula, it looks better. That's why. So sine square theta plus cos square theta is equal to 1. Got the idea? Now let us prove secant tangent identity. So it says 6 sec square theta minus tan square theta is equal to 1. So everything always starts with Pythagoras theorem. Uh, okay. Uh, so I've just taken this first. I've just told you that I've just written down second. Second means what? Now remember the very first slide that I showed it to you. Let me go to that slide. Yeah, do you remember this slide? Remember this slide. When I say sec, it means hypotenuse upon adjacent. When I say cot, it means adjacent upon opposite. Okay. So now let's get to our uh, proof. So here let's prove this identity. Uh, so what will we say that sec means what? Hypotenuse upon adjacent square, and uh, tan means opposite upon adjacent square. Now as you can imagine, I'm distributing the square sign in the between numerator and denominator, so I'm distributing it, and then I'm taking the denominator common. Okay. And then as per the Pythagoras theorem, we know that hypotenuse square is equal to adjacent square plus opposite square. H square minus O square means what? See, H square here, I'm taking O to the left hand side, so its sign will reverse, and see, this is actually equal to A square, right? So here instead of this I can write A square. Okay, so A square by A square, and then it equals to 1. So this proves our secant tangent identity. Everything is getting proved by Pythagoras theorem only. Okay, so just remember the Pythagoras theorem and the very first slide that I showed you, that when I say secant, then what does it mean? It means hypotenuse upon adjacent. When I say tan, it is opposite upon adjacent. Okay, so just remember that first slide and remember Pythagoras theorem. That is sufficient. Secant cotangent identity. How will you prove it? Again, starting from the Pythagoras theorem. Then you will say divide both of them by a square. So what will you get? You'll get something like this. Now this equates to 1, and as you can imagine, this I'll flip to the other side, and then I'll take the square common across the numerator and denominator. And what is this, by the way? Oh, this is cosec. And what is this, by the way? This is cot. So hence proved. It is very, very simple. Just remember the first slide and the Pythagoras theorem. Got the idea? And try practice it once or twice. See, the main problem in proving it like this is that, see, when I tell you that h square is equal to a square plus o square, you understand. H means hypotenuse, a means adjacent, o means opposite. You get it, right? But in the schools, you are not taught like that. This triangle will be a b c triangle, and then you'll say let angle, now what was AABC. So you'll say angle BAC is equal to theta. Let us imagine that angle BAC is equal to theta. Then let's prove this identity, and then see, you will keep on naming these angles as BAC, ABC. You don't understand it, or you will be naming the sides as AB, BC. It is so difficult to remember. That is the main problem. Otherwise, if you just name them something logical, it is so easy to prove it. It's not even like 4 lines of code. I mean, 4 lines of, uh, you know, 4 lines. But see, I'll show you an example how difficult our teaching system makes it. See, you will start your proof like this. Let triangle ABP is be a right angle triangle. अरे यहाँ पे B चाहिए था, it should be B over here. A right angle triangle where angle B is equal to 90 degrees. Okay, then you will say let angle PAB be equal to theta. This is how. So this is what really makes it difficult. Then everywhere you are referring to the sides with two numbers, two alphabets, two alphabet. So it is difficult to understand, and that's the reason why maths becomes difficult for people. And so I have tried to name a side by one letter. It is easier, right? I hope the schools write something like this. Even I used to find maths difficult, but it was mostly due to the way it was written. I understood all the concepts. But, while making, I used to make silly mistakes, and there was no scope for silly mistakes because it is difficult here. I mean, who will remember the sides and this and that? I get the concept, right? So I really urge, I don't know whom am I urging. Anyways, no one sees my videos anyways. But yeah, that is a grievance I have with our current education system. We make it too complicated. Okay, let's go ahead. Advanced trigonometric formulae. So you also remember this slide. So one slide you have to remember the first one. Second slide you should remember this one, and third you should before you start your exam, just draw the trigonometric table of standard angles. Okay, draw it, means write it down on your own. Okay, that is all. This should get you through the trigonometry. So here, let us go through them one by one. Advanced trigonometric formulae. Tan theta is equal to sine. This we already know. Cot is equal to cos by sine. We know that. Co-function identities. So here, cos of 90 minus theta is equal to sine theta. We have already seen this. We have seen for 180 degree also. So these are what trigonometric identities for complementary functions, complementary angles, and similarly we saw it for supplementary angles also. So this is nothing. Okay, reciprocal identity. So you know that cot is a reciprocal of tan. I have used the word reverse many a times, but it's not reverse, it should be called reciprocal. Reciprocal means suppose a is equal to 1 divided by b, then a and b are reciprocals of each other. Okay. Cosec is the reciprocal of sine, and vice versa. So similarly you can say sine is equal to 1 divided by cosec. Okay, so this is how it is. Similarly sec and cos are reciprocals of each other. Odd or even identities. So when you say sine of, actually it's not even odd identities, it is negative positive, you can say. So when you say sine of minus 30 degrees, it is equal to minus sine of 30 degrees. Okay, cos of minus theta is equal to cos of theta. Tan of minus theta is equal to minus tan theta. Getting the idea? See, this negative sign of the angle affects sine, but it doesn't affect cos. Cos is the same. Okay, negative, it affects tan, it affects cot, but it doesn't affect sec, because sec is what? Sec is the reciprocal of cos. So it doesn't affect both of them, and it affects everybody else. Okay, even cosec is getting affected. Then half angle formulas. So you know theta by 2, when you do theta by 2, then what will happen? So this is the formula. No, even if you don't remember this, I don't think it will be asked, but I don't know, just check your syllabus. I don't know, but I think this is quite too much. If it were to me, I would not ask a 9th standard person anything even remotely close to this. Well, it's too complicated, it's not needed, I mean, given the age of the person. But look at your syllabus. I don't know. Okay, I have been into 9th long time ago. Okay, now Pythagoras identities. Now these are identities. Okay, they call identity. I don't know why. Okay, at least they have one into them. So yeah, you can call them as identities. So Pythagorean identity. Oh, all these three are called as Pythagorean identities. I didn't know. I basically called them by different names, right? If you remember here, I called them by the name of Pythagorean identity, secant tangent identity, and cosec cotangent identity. But see, in one other tutorial or one other material that I found online, they are all mentioned as Pythagorean identities, and it is very logical also, because all these three can be proved using Pythagoras theorem. So yes, it is more logical. I would rather say, yeah, they should be called as Pythagorean identities only. I'll correct myself. I'll stand corrected. Let me correct my stand. I think that is more logical. So let's call these as Pythagorean identities. Okay, and these are those identities. I'll just copy this part. I'll remove the whole thing. Yeah, these are Pythagorean identities. It's a learning for me also. I'm also learning along with you. Okay, so these are Pythagorean identities, and yeah, this one. Let me just design the table a little better. Okay. Okay, now coming to our last slide. See, this slide we saw, everything we saw on this slide. Next slide is, what is a real life application? So I come from B Electronics and Telecommunication, means Bachelor of Engineering, Electronics and Telecommunication. So there we saw what is sine wave, what is cos wave, right? So this is the use of trigonometry in the real world. So sine wave means something like this, which will start from 0, it will go up, it will come back, it will go down, it will come back. That is called as sine wave. Cos wave is just this wave moved by 90 degrees. So this is moving towards the left by 90 degrees. So it starts from top, okay, it goes down, all the way down, and then it comes all the way up. Okay, so that is cos wave. Similarly, you have tan wave, cosec wave, sec wave, and cot wave. Got the idea? So basically this will be the real world application. Other than this also, there are a few real world applications which you will see in the exercises. So let us try to use our knowledge now. Find all the trigonometric values of sine theta if sine theta is equal to 4 by 5. So it means to ask us that, okay, then what is cos theta? Do you know? What is tan theta? Do you know? I'm just giving you sine theta and you find everything else on your own. So let us see. So sine theta is equal to this. So this must be, what is P? It should be opposite upon hypotenuse. So it should be, opposite side is also called as perpendicular. So I've written P over there. So let us assume that P is equal to 4x and H is equal to H is hypotenuse. Okay, I'm getting confused here, man. I'll change it. If I'm getting confused, you will also get confused. So let us remember, and let me paste that triangle also here, so that even for me it is difficult to remember, no? Yeah, this thing I'll copy this and I'll paste it over there for you also and for me also, because it is difficult even for me to understand. Okay, okay. Here opposite, no, I should be calling it as opposite. So opposite upon hypotenuse. Okay, now let us assume that P means opposite is equal to 4x, and because it is 4 by 5, right? So and height is equal to hx, means 5x. So what is there to assume in it? It's actually true only. Okay, 4 multiplied by some number it is, right? And hypotenuse is 5 multiplied by some number. Okay, so as per the Pythagoras theorem, hypotenuse square is equal to opposite square upon see, this B means base, so adjacent square plus adjacent square plus opposite square. Okay, now just put the values here. So it will be 5x square is equal to 4x square plus you know a square, that is adjacent square. So adjacent square is equal to 25x square minus 16x square, and then adjacent is equal to something like this, so it will be 3x. So adjacent is now 3x. So your adjacent is 3x, your opposite is 4x, and your hypotenuse is 5x. Now let's take the same values over here. Again, I'll just copy the same values and I'll put those values here. Got the idea? Now for these values, it is very easy to find out. Okay, so what did we do? We found out what is A means adjacent, what is opposite, and what is hypotenuse. Now just put those values into sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta, and you will get the respective values. And that is what was asked in the question, that find all the trigonometric values for sine theta. Sorry, if sine theta is equal to 4 by 5. Sine theta was already given, so there was no need to calculate this. But yeah, cos till cot, yeah, they can be calculated like this. Got the idea? Simple. Now, exercise number 2. It says that, okay, I have some left hand side. Now calculate the right hand side. Okay, so how will you do that? From the trigonometric table. So first of all, trigonometric table, I told you earlier that as soon as the exam starts, you will be given the answer sheet, right? So you'll be given the answer sheet before the exam starts. You have around 5 to 10 minutes, right? During that time, just draw this trigonometric table, at least for standard angles. Okay, once you do that, um, you know that cos 45 degrees is what? Oh, okay, it is 1 by root 2. Okay, sine 60 degrees is what? Sine 60 degrees is root 3 by 2. Tan 60 degrees is what? Okay, tan 60 degrees is root 3. You know it because you have drawn this table already. Okay, then you just put these values in. So the values are put in, and then this is basic algebra. You can do that, right? There's no problem. You can always, this 2 and 2 will get cancelled, and now this root 3 and minus root 3 will get equal to 0. So now this it will finally give you 1 upon root 2, and that is the answer. The right hand side of this equation will be 1 by root 2. Okay. Exercise number 3. Now let us say that you don't get standard angles. Here you got standard angles, right? So it was easy for you to calculate because you already had this table drawn. Even before the exam starts, you will draw this table. Okay, so for standard angles it is easy, but for this kind of angles, what will you do? So you try to break this angle into some standard angles. Okay, so let us divide it, let us write it like this, that 50 degrees is what? 60 degrees plus 90 degrees, right? So these two are standard angles. Okay, and then you know that sine of a plus b is equal to sine a into cos b plus cos a into sine b. Okay, this is one more formula. We should I should have mentioned that formula as well. So this is a very important formula. Remember that. So here just use that formula, and you'll get sine 60 degrees into cos 45 degrees. 45 degrees. Mm, it should be 90 degrees, no? My bad. So you get the idea, right? You calculate accordingly. Okay, it should be 90 degrees, and that's why my answers are wrong. Okay, and yeah, so cos of 90 degree and sine of 90 degree, what is it? Let us see. Cos of 90 degrees, okay, 0 and 1. Okay, so this will be 0 and this will be 1. Okay, so this will evaluate to 0, and this will evaluate to 1 by 2. So the final answer is 1 divided by 2, 1 by 2. Okay, so this will be the answer of it. Let us just check whether the answer is correct or not. So you can always go to Google and you can just search what is the answer. Okay, it is 1 by 2. So we are right. Okay. So this is how you do the calculations for bigger angles, which can be broken down into supplementary or complementary angles. Okay, means which can be broken down into standard angles. Okay, but suppose you have 155. Now that cannot be broken down into supplementary angles. So this logic won't apply there. But in most of the cases, and especially in 9th standard, I don't think people should be asked very difficult questions. Now let's take a real world example. Uh, a boy sees a bird sitting on a tree at an angle of elevation 30 degrees. So let us imagine that this boy, uh, maybe this tree is the tree at his home, and he is sitting in neighbor's house, maybe like that. So the distance between the tree and the boy is like 10 meters, and this being a standard angle, you can guess about standard angles. So elevation, the angle at which the bird is sitting is probably 30 degrees. Okay, then Suppose that this boy now wants to know what is the height of this tree. I really want to calculate. So how will he do that? So first of all, tan of 30 degrees is what? Opposite side upon adjacent side. So opposite side is the height and adjacent side is uh, 10 meters. Because see, I have this given and I want to find this. So which formula has this? Either it is tan or cot. Cot means what? Adjacent upon opposite. Uh, Tan means what? Opposite upon tangent. Opposite upon adjacent. So I'm using this formula. Then here, I'm just writing here, instead of opposite side, I'm writing height. Instead of adjacent side, I'm writing 10 meters. So height is equal to what? 10 meter multiplied by tan 30 degrees. Now what is tan 30 degrees? So there is this table, trigonometric table that I have already drawn, right? So tan of 30 degrees is 1 divided by root 3. So let me calculate it. Oh, the value given here is wrong. Yeah, it will be 1 divided by root 3. Root is drawn, I think, like this. Yeah, 1 divided by root 3. And so the value here is, uh, 10 divided by root 3 meter. Okay, so this is the final answer. Okay, so that is how you will solve real life examples, real life challenges using trigonometry. This is called as applied mathematics. Apply it in the real life. Okay. Next, now this is the kind of questions that you will actually be asked in the exam. And here purposely, I have taken the sides in such a way that it does not give you a very beautiful answer. Okay, so let us see. If you are asked to figure out the values of tan x, cos y, so on and so forth, then how will you do that? So first of all, use the Pythagoras theorem and find this side. See, find all the sides first. Okay, so you know this side, this side, this side. You don't know this side and this side, right? So AB and AD has to be calculated. So use the Pythagoras theorem and find AB. Okay, you get the AB. And then AD you will get as 12. Okay, because you'll use Pythagoras theorem on this triangle, right? So you'll get 12 over here. Now after that, you try to calculate the first value. So it is what? Opposite upon adjacent. So whatever are the values, that is the answer. Okay. Then cos y. So cos y will have what? Adjacent upon hypotenuse. So this is the answer. That's why I said answer is not very pretty in this case. Purposely I gave non-pretty kind of answers. So it is 0.78 something. It's not a whole number. Okay. Similarly, the third one, you'll calculate like this. You'll put all the form. You'll expand it into formulae like hypotenuse upon opposite. So then you'll put the value of the hypotenuse upon opposite, and so on and so forth. You'll get 1. And then finally this one, I purposely try to make it as ugly as possible. And finally, see, the value that you get is 14.04. Okay, so this is how you basically solve this kind of question. So whenever you solve this kind of questions, find the length of all the sides first. Okay, and then you just evaluate these functions as and when you encounter them. Okay, and these are all the sources from which I gathered all this information. Or actually, I'm not taking any of the information as it is, except I think the formulae PPT and some other such PPTs where I copied the formulae directly. But otherwise, normally I try to put my own touch into it. But yeah, these sources have been very, very useful to me for making it possible to deliver this kind of a session. Until next time, Jai Shri Ram. ये है अमित शिरासाव, अमित शिरासाव, अमित शिरासाव, अमित शिरासाव.